if I go back to the original exponential functions, that's my base, that's my exponent. If it's greater than 1, it's growing. If the base is between 0 and 1 or a fraction, it's decreasing. Both graphs I showed you did that. Compound interest. In general, what does interest do to money? Increases it. So the graph is going to look something like this. It is possible, though, to decrease. What's going to happen there? There's one thing I did not write in this formula. In the middle, it could be a minus. That's if you're losing money. What I mean by how many times it's compounded. That means how many times is interest generated. If it's yearly, how many times is it generated? Once per year. How about monthly? How many months are there in a year? 12. So if I said some sort of problem, it's compounded monthly. 12 would go there, 12 would go there. Let's look at this problem. You invest $250 of your money right now at 5.5% per year. What's that? Yeah, but here's the thing, that this is really good. 5.5% now is very, very good. You're lucky if you get 1%. You have to put a certain amount in. Yeah, $250, you're not going to get $1 million. Sorry. We're not miracle workers here. The way money works in a bank, you put money in a bank, you're loaning that money to the bank to do whatever they want with it. They give it out to other people. Because you're giving the bank your money, they give you a certain percentage. So we're going to put money in the bank you got for your birthday. You're going to put it in the bank for 5.5%. How much will you have in college, or sorry, when you graduate high school, which for some of you will be this year. When you graduate college, well, so this is this year. College would be how many years from now? 5 years from now. Why 5? You count this year plus 4 years of college. And then for 30, when you're 30. All right, most of you are how old? 18. So we'll just say 18. How many years? How many years till you're 30? 12. So we have 3 problems here. The way we set this up, A equals, how much money did I put in the bank? 250. 1 plus, now this is where you have to be careful. What's my interest rate? 5.5%. But I don't write 5.5%, I write 0.055. Move the decimal over 2 places. To the first power.
Do you have to put that one up also?
You don't have to, because everything is just automatically given to the first power. This is the only work I need to see. You set it up, you put equals, we use our handy dandy calculator. 250 to the 1 plus 0.055. I'll just put to the first, but I don't need it. So after 1 year, I have $263.75. I know it does not sound like a lot of money, but this is money for after 1 year. It's just sitting somewhere. And for it sitting there for just 1 year, you get $13 off 250. That's not bad. If I were to change this to a bigger number, actually I want to use this. Let's say I put, instead of 250, I made it 2,500. How much money did I make? I made $100 and some, right? How about if I had enough money to put in 25,000? How much money did I make? $1,300. So you're just going to go up, and every zero you add another zero to how much you make. The more money you put in, the more money you make. That's why people who are millionaires stay millionaires. Because if I put $1 million, let's see, this is 25,000. Let's change it to $1 million. How many zeros do I have? 4, 5, 6. How much money did they make? 1 million. They made $55,000. Not bad. That's $55,000 they just get for having $1 million in the bank. Some people can live off that. All right, for college, A equals 250, 1 plus 0.055 to the what power now? To the 5th power. Because when you graduate college, it'll be 5 years from now, hopefully. So when you graduate college, that $250 would now become $326.74. I want you to find out how much money would be in there when you're 30. For when you turn 30, A equals 250, 1 plus 0.055. Some of you are 12, some of you are 13, some of you are 30, whatever. Put 12. I should not have to retype this. If you're smart, once you get the first setup, you write it. Then in here I go second, enter, change the 5 to a 12. When you turn 30, there will be $475.30. So you almost doubled your money. What's that? If you take money out, then this money changes. But say you went after 5 years and you took out $20. Then what happens is you start from scratch again, minus $20. So instead of being $326, you only have $306, and now you're starting from square one. If I said after 5 years I took out $20, then you start at 306, and this would only be 7. You can't go the full 12 because you took a piece out. This problem looks very familiar, except for what? This is compounded quarterly. So rewrite it, or you can just say, how about compounded quarterly? Same exact numbers, but something has changed. It now says quarterly. The formula changes in 1 bit. For high school, college, and when you're 30. The high school. A equals how much money? 250. 1 plus 0.055. This is where it's different. What does quarterly mean? Well, quarter means 4. So I divide by 4. And up here, it's going to be 4 times 1. Now I'm going to go back for a second. Here's the original formula. N is there. If it only happens every year, it's only happening once. So that's actually a 1. That's a 1. Nothing happens. I want you to try these two. Try all 3. Be careful on these, though. This is where you have to be careful. Divide by 4. When I do the power, either do the multiplication ahead of time or put it in parentheses, 4 times 1. And I get $264.04. It changed it by about $1. Okay, for the second one, A equals 250. 1 plus 0.055 divided by 4 to the 4 times 5. When I put it in the calculator, I either put 20 or I do 4 times 5. If you do 4 times 5, it has to be in parentheses. I'll show you if I don't. This is $328.52. If I don't put the parenthesis, and I just do to the 4th times 5, I get 1,300. Now, this, if you actually think, I went, in 1 year I made, I had $264. After 5 years, I have $1,000. I took that $250, and now it's well over 1,000. I did something wrong. Because all you did is took that number and multiplied it by 5. The last one, 250, 1 plus 0.055 divided by 4 to the 4 times 12. 4 times 12 is 48. After 12 years, I have $481.53. It is a difference of about $6. By the interest changing quarterly, you made $6 more. That's an 8. My 8s don't like to show up always on the board. So that's why I started doing that. Here's another type. Yeah, this. All right. When I originally wrote this lesson, gas was 3 1/4. Now it's, I think, 350. The price of gasoline in 1994, I paid $1.50 a gallon. Now, it's $3.50 per gallon. We want to find out what's the annual rate of inflation, aka what's the percent increase in price. This is also called the effective yield. So we want to find out what percent did gas go up. We're going to use the exact same formula. A equals P times 1 plus R to the T. I didn't put divided by N. Why? We're talking about years. What does A stand for? In general, the final amount. P stands for the principal, which is my original amount. What's my final amount of gas? $3.50. What's my original price of gas? $1.50. 1 plus, I don't know the rate. How many years have passed? 16. Are you sure?
No,
17. You haven't had your birthday yet. So it's 17. Yeah, it all depends on exactly what time of the year it was. We're saying January and January. I haven't done anything yet.
Was the 350.
350 because that's the price right now. I put the 150 because that's my starting point. 1 plus R because I don't know the rate. And T is 17 because it's been 17 years. What do you think my first step would be? We have to get R by itself. What do I have to move first? The 150. Divide 150. So I have 350 divided by 150. 2.333. 1 plus R to the 17. Now, how do I get rid of something to the 17th power? No. All right, let me get rid of the 17th. This is a little side note.
I know what I said.
If x squared equals 9, how do I find out what 9 is? Take the square root to get rid of the square. If this was x cubed and this was 8, I take the cube root. What do I do for this problem now? I take the 17th root to get rid of something to the 17th power. Now, the fastest way to do a 17th root on this calculator. 17, math, 5. That says the 17th root of, and I'm just going to go second negative. And it just says ANS. What that means is it's going to put in the 2.3333333. It's going to be more accurate than just putting in 2.333. Enter. 1.051 equals 1 plus R. By taking the 17th root, that got rid of the 17th power. Now what do I do to solve? Subtract 1. Subtract 1, subtract 1. And I'm left with 0.051. That's talking about the rate. I'm going to change it back to a percent. What percent is 0.051? 5.1%, and this went up. So the price of gas went up 5.1%. Do you see how we work through this? The cost of my car, when I bought it in 2008, was $25,000. Now, it's worth $11,000. Whenever you buy a car, the first thing you take it off the lot, it starts losing money. How much did my car decrease in value, percent-wise? I want to see if you can figure this one out.